Hello again, my fellow Jeti users, and welcome back to my workshop for another of Harry's Jeti Clinic videos. And in this one, we are going to be taking a look at another lovely LUA application from Dave McQueenie called Virtual Sensor Extended Functions, or as you can see in the model name here, VSense-xxx for short. Why that name? Well, what Dave has done is take an existing application from Jeti called Virtual Sensor, and he has removed some of the limitations of that app and greatly extended its functionality as well. So to give credit to Jeti, but to differentiate it, it's called Virtual Sensor Extended Function. What is Virtual Sensor app? Well, it allows you to take numbers from your existing telemetry sensors and do some arithmetic or logic on them to produce a new answer, which you can then use. For example, a Jeti MUI sensor will give you volts and amps, but it doesn't tell you the power in watts, and that could be useful to have. Well, power is very simply volts multiplied by amps. So if you had a way of doing that, and you had it, and you could log it and see it and hear it, you've now got a good power meter. Another example would be on your glider. If you have a vario and an airspeed sensor, you can calculate the glide ratio, which would be very handy for trying out different elevator trims and speeds to see which one gives you the longest gliding distance. Another example would be, and what actually kicked off Dave rewriting Jeti's app into this, was a request from someone who wanted the transmitter to tell him if the engines on his twin engine model had gone out of synchronization by some particular different RPM. You can use Jeti's inbuilt logic function to tell you if something is different, but it would be different by 1 RPM, which is no use. You want it to be some nominated amount. So this app does some fantastic stuff for you. It is really like having a little spreadsheet in your transmitter that you can do all sorts of numbers and calculations with. There are going to be 3 episodes in this series. This first one will deal with getting the app, looking at it and its various menu options and how you basically manipulate it and use it. The second video will look at the request that kicked this all off, which was about a warning when twin engine models' engines have started to differ by a certain RPM. And the third one will look at the special GPS functions that Dave has built into the app that allow it to do some very basic no-fly zone warnings to you. And if you want no-fly zones and you've got a color screen, such as this transmitter here, really you should use Dave's Google Maps app, because it's far more powerful and sophisticated and easy to use. But if you have one of the original 14 or 16 transmitters with a monochrome screen, this app will let you do some basic no-fly zone and warnings for you. So that will be episode 3. So why need this rewrite of the original Jeti app? Well, the original Jeti app does not run on the original 14 and 16 transmitters with a monochrome screen. I did try it on a 16, but it would crash after 2 seconds or 10 seconds. It just never ran long enough to be usable. And when I asked Jeti about it, they said, oh well, in that case it doesn't. So although it tells you on Jeti Studio that it was suitable for the 14 and 16, it isn't. This app, despite being vastly more powerful, does run on the original 14 and 16, with the exception that a supplementary part of the app, which allows it to announce various things, cannot run on the 14 or 16. But you can still get announcements. If you can trigger a switch value, you can use it in sounds on event, so you can still have some voice announcements. The original Jeti app only outputs to a displayed telemetry box, so unless you can look down at the screen at the time, it's of no value to you. And if you've watched any of my videos, you'll probably have heard me say many times, my golden rule: never take my eyes off the model. I certainly do not want to be looking down at the screen. It's all right if you're running up on the ground and you want to look at the power number, the watts, but you can be doing many other things. You can't be looking at the screen. This app, it allows for logging, so you can review things later in Data Analyzer or Jeti Studio. It allows you to have it as a switched output, and you can use that switch to trigger, for example, sounds on event. You can use that switch to run functions, rates, modes, whatever, although I would suggest you go extremely carefully with what you let it do in that type of thing. If you were to use the app to switch harmless things like lights or sounds on the model, that's fine, but don't let it anywhere near flying controls or do anything of danger. And as I mentioned earlier, if you have the transmitters with a color screen, the app has a built-in announcer, so you can actually have it speak out the values that it's come up with. The original Jeti app only had one calculation in it. This allows for many, many different calculations, like having many different rows or columns in your spreadsheet. The original Jeti app only allowed 2 telemetry inputs, so those were the 2 values you could work with, and that was it. This allows many different inputs. Also, you can use the answer from one formula as an input into another. Imagine in a spreadsheet you take the answer from one cell and take it to another cell to do yet another calculation. You can do that with this. The app has some special extra functions built into it, and we'll look in particular at 2 of them in the second video, but it really does have some very good stuff built in to save you having to try writing some hefty mathematics or equations. It also has the special GPS no-fly zone functions and some other GPS functions. As I say, for those of you with a monochrome screen, can do a little bit of basic no-fly stuff. And Dave now has the ability, and has put it in this app, to put in help screens. So a button will appear with the little speech bubble, button F1, when you're in the app in here. And depending on which screen you're in, when you press it, it will bring up quite a lot of text explaining things about how to use the app and how some of the special functions work, what they do, how you put data into them. And I'm going to be assisted today by this lovely device here. It is a test sensor. It comes from the design at the rc-thoughts.com website. Very clever Tero designs these, and so what it does is allow me to emulate the numbers from 2 telemetry sensors. So I can use one as, say, volts, the other as amps, or it could be revs from the left engine and right engine, could be vario and airspeed, whatever you want. And so that will allow us to work this demonstration very well. So if you do a lot of programming with your sensors, it's well worth having. It allows you to test a lot of your programming on the ground without having to get airborne and then find that some of your programming with your sensor numbers wasn't right. Okay, to get to the app, you get it from Jeti Studio. If you haven't already done this next step to get Dave's apps beforehand, have a look in the description box below this video. There is a link in there. Copy that link. Go into Jeti Studio, and if you're using a PC, because a Mac or Apple computers look a bit different, I don't know their menus, but on a PC, it's File, Configuration, and then look for the Apps Sources tab. Click on that. There's a box in there, and paste the link in there on a new line. And from then on, when you connect your transmitter and go into the LUA app manager, it will show you the list of apps from Dave McQueenie. There'll be DFM- and then the name of the app. if you're curious, it won't include the Google Maps app because that uses its own very unique to you address. So that's a different thing. Okay, and then look for it, DFM-xxx, put it onto your transmitter. To use it, go into Applications, User Applications. This is another of Dave's apps that I use on every model, and I've already installed it here because I'm going to show you how two of his apps can interface with one another. It allows you to do 1, 2, or 3 short presses or a long press of a button or a spring-loaded switch and get different numbers read out, different functions running, etc. So press plus and come down to vSense-xf. You will also notice that it has loaded this one, VAN, which is the announcer app. Now, you don't have to tell your transmitter to load this one up. Just load vSense-xf. It'll have taken that one with it as it put this onto your transmitter, but you don't need to tell the transmitter to run this in the model. Do not delete it or the announcer won't work. What happens is that if you use the announcer that's built into the extended function app, it will just call on the announcer app as it needs it. So that's the only one we need to install. Right, let's go into it. Telemetry variables. This is where you start off by telling it what telemetry things you want some of your equations to work with. I've got sensor 1 and sensor 2, of course, linked up, but you can put in quite a lot more telemetry variables if you want. Press plus to create, and the first one it finds is telemetry 1, so you can rename that if you want. Just for the sake of argument, we'll call this one volts. Oh dear, dear, dear. I need to backspace that one out. Okay, and then you tell it what telemetry parameter it's actually going to be picking up. Now, of course, at the moment, it's just saying I've got sensor 1 and sensor 2 from RC test, but if you had an MUI hooked up, it would be offering you all the different items from an MUI. In fact, it will offer all the different items from all the sensors you have linked up. Okay, and I'd want one, we'll call that one amps. And again, you'd go and find your MUI amps or whatever it is you're after. And you can keep adding more as you want. Beware of pressing the reset button. What it will do is clear out everything, not just the one you're highlighted. Okay, so take care of that. Don't just go and press reset and then go, I've just spent 2 or 3 minutes setting it all up. Okay, and then we come to here, the result expressions. This is where you write your formulas. Again, press plus to create. Notice here the little speech bubble with the question mark. If you press that, you get help. And you can scroll down. And as you can see, Dave's written a lot of help files for you there. And a lot of it is about how some of the very specific functions built into it work and what you need to do with them. So you'll press plus. Again, beware of pressing reset. It will wipe out all the multiple expressions you have. You can press plus and create more. You can have result 3. You can have 4, and so on. Press reset. It gets rid of them all. Plus, we only need 1 at the moment. Now, this is where we write our equation. Along here is a long, in effect, circular list of all the things you can put in. It picks up the telemetry sensors we created, volts and amps. If we hadn't named them, it would say T1 and T2. Remember, we changed the name from T1 and T2. So we can say volts, and then we'll start scrolling along till we find the multiplication symbol. See how the one that's being picked up is in bold. So there, press this programming dial, times, amps. And there, it tells you. Straight away, it's got the result. Okay. Now, you can keep scrolling along. See, you've got basic arithmetic there, bit more mathematical symbols. Incidentally, if you use things like the greater than or less than, it does a logical test. And then the result would be either a 1 or a 0. It's true or false. Yeah. Same with the equals things, a little bit of logic. Here's where you can put actual numbers into your equations, and then some really good mathematical stuff. We'll be covering step and box in episode 2, some of the stuff for GPS, and result 1, which is the output of this, now becomes one of the variables you can choose. So, for instance, in the second equation, you could take result 1, put it in, divide it by 1,000 would give you kilowatts. Yeah, in fact, we'll do that just to show it. So we're happy here, volts times amps, result, done. Let's just show what you can do. We'll take that one. We're going to create a second one. First of all, let's name this one. We'll call it power. The reason I'm doing this is, first it'll show up in the list of variables we can put in, but this is what will show in the name of a displayed telemetry box. Say OK to that, and its unit is going to be watts. You don't have to name these things, but I'm doing it to show you the effect that it has. Okay, now let's come down to result 2. We'll just leave it as result 2, but its unit will be kilowatts. And result 2, well, we could go through it again and say volts times amps divided by 1,000, but we've already done that bit, so we can just say power. So it's taking result 1, in effect, power, divided by, now here's where we choose an actual number, 1, 2, 3. Say OK. And there we are. We'll take that for the moment. Say OK to those. Now, if you want to show it on a telemetry window, you have to set that up. And the reason being is that Jeti only allows a LUA application to show 2 telemetry windows. So what we do is we go in here and we choose which of our equation answers is going to get the chance to show in a telemetry window. If you only have 1 or 2, that's fine. But if you had 3, 4 or more equations, this is where you get to choose who's special and gets it. So you'd go in here, telemetry window 1, we choose which one you're after, telemetry window 2, result 2, that's fine. Yeah, so it just lists all your results that you've got. So they're okay for that. So that's that done. And what we can do is go to timer sensors, displayed telemetry, press plus, go into LUA, show that. You can double size it, and then remember it will show the lowest and highest values, which is a nice quick way of seeing what's happened without having to go through to Data Analyzer to have a look for the highest values. So I'll just choose that to show it, and then result 2, we can say no to that one. And there, now on our front screen, so imagine this is from your MUI, volts and amps. Now you've got power, so it's showing as kilowatts because underneath here it's showing 0 to 1.56 kilowatts. In order to get the low and high values in, it would take so much text that the app is very cleverly shortening that. So let's turn it down to small numbers. Reboot it. There we go. See how it's showing watts there, because that's what we typed in as the unit to show is watts. and this one's showing kW. But Dave's writing of the app is so clever that in order to squeeze everything in, once it gets up over a certain value, it just can't squeeze everything into that line, and so it drops it automatically into kilowatts for you. So that's why, even though we typed watts in as the name, it shows kilowatts down there. Right. So what if you wanted a value to trigger an announcement, or to trigger switching on the lights, or a sound system, or whatever? Well, here we go back to the app. And to a result expression. What we need is an equation that will just output a switch value, i.e. 1 or 0. Now you might be thinking, well, can't we do this within Jeti's built-in stuff, such as telemetry controls? But there are two things that Jeti will not allow LUA to access, and that is telemetry controls and the voice output. Both of those will work only with actual telemetry sensor values. So even though this LUA is working on telemetry values, its output is not a telemetry value as such, and therefore we have to do any testing that you might normally do in telemetry control, we do it within the app. So let's create another line, and we'll result 3. We'll say if the power, which remember was in normal watts, not kilowatts, is greater than some value, let's pick 1500. Okay, and that's it. So if power is greater than 1500, the result will go to 1. So I'll turn up the amps. You see it goes to 1. I'll turn the amps down, goes off. So now we have an on-off switch basically at 1500 watts. Let's take a look at that. And what you have to do is say a LUA control. We'll create a LUA control. LUA control VO1, what's it going to pick up? Result 3. Because you can't have a control that has, you know, whatever wattage in it. It must be the on-off switch, which is what we've created from that wattage. Okay. And we can then go to Advanced Properties, Sounds on Event. So we go into the switch, press plus, come down to User Apps. There it is. Say OK to that. Then choose our file. I'm going to say maximum power exceeded, which is a little voice file I made specifically for this demonstration by going to the rc-thoughts.com website and using their text-to-speech software that's on there. Okay, can do that. So now if we go above the value, what was it, 1500 watts?
Maximum power exceeded.
There you are. So I say that switch is there. You can use it in just about anything that accepts a switch as an input. Next, let's prove that logging works. At the moment logging is switched off. I'll press start, round dot, logging is running. And so we'll change some of the values.
Maximum power exceeded.
Ooh, yes, thank you. Bring it down here a little bit. We'll just run it for a short time. Press stop so that it actually closes the file, creates it for us. And now we can have a look in Applications, Data Analyzer, select our log file from that model, down, select our variable, and there we are. It's listed as TX, so the power, result 2 and result 3. Result 3, of course, is just going to be 1 or 0 because it's a switching value. Result 2, the kilowatts. we'll prove it here. We can have a look at the wattage power as I was moving it around there. Have a look at that. There you go. So the whole thing is available for you to check as you need. Okay, back into the app. Have a look at what else it can do. Well, we've had a look at inputting your telemetry variables. You need to create the telemetry windows. We've had a look at creating the calculations, the controls from it. Sensors and points for the GPS will come to in episode 3. Announcements is the remaining thing. So you can have it announce values in various methods. And the reason the announcer is built in is because, yes, you can use the sound on event, but then you have to have a specific WAV file to read out. What if you just want it to read out the watt numbers? Well, there isn't one specific file to read out 870 watts or 230 watts or whatever it is, your glide ratio, whatever you're doing. So here's the announcer. Press plus. Take the one you want to be announced. We'll have power. And there are 3 types of switching you can use. Periodic, it will announce every X number of seconds. Auto, it will announce based on an algorithm in the app every little while, but the more rapidly and frequently your numbers change, the more rapidly it will, or more frequently it will make the announcement. So if there's little change, it'll be a long time between announcements. A lot of fast change, it'll be a short time between announcements. Edge is just picking up whether a switching has occurred. But it's quite sophisticated. You can pick up an edge from 0 to 1, 1 to 0, 0 to -1, -1 back to 0, that kind of thing. For this example, we'll look at periodic. We go into it to edit. Now it does need an enabling switch. If you do want to accept it, simply reading out every 10 seconds, it's the default, you can change that. Then you need to set this up to be log max, in other words, on. Because without a switch being on, the announcement isn't going to work. To do that, you go into here, logical switches, log max, say OK. Now, result name audio and units audio are files.
612.
Thank you. The name. Do you want it to say power?
612.
Preceding the number. And then units audio, do you want it to say watts after? So result name audio is what it says before it reads you the number. And units is what it says after it's read you the number.
Power 612.
Okay.
Power 612 watts.
So the next time round it'll pick up the new number.
Power 1116 watts.
Okay. And
power 252 watts.
Edit. You can change the decimal places if you like.
Power 252 watts.
Because it's 0, it's not bothering to say it, but if there were decimal places there, it would give you
power
those.
252 watts.
Okay. What if you want it just on demand? We'll change your enabling
power
switch to
252.
I'll use a spring
watts.
switch, could be a push button, whatever. There. But also you want to bring the period down to the minimum of 2 seconds. Otherwise, if you pulled it, heard something, pulled it again, it would still be waiting the 10 seconds before it would work again. But now we can get it on demand as required.
Power 252 watts. Power 612 watts. Power 1116 watts.
Okay. Now, I mentioned you can use it with another app. That's Dave's short press, long press app. So let's pop into there. Short, long switch. I'll go for 2 presses. I've already set it up as SG, pull towards us. I'll set that then to be a function, because it can't read out from the LUA app itself. So set that as a function. Say OK to that. In here, I'll remove, edit the enable switch from there. Okay, so now what I want is the enable switch to be from the app, the 2 press button there. Okay, and now if I pull the switch twice or press the button twice quickly, we'll get the readout. If I do it once, we won't. So here's 1, here's 3, here's a long press, but now if I do it twice,
Power 1116 watts.
There you go. That short press, long press app, as I say, is something I use on every model, because I'll use, say, 1 press for height, 2 presses for milliamp hours, 3 presses for something else, long press for something else, as needed, often just the 1 and 2 presses, but it'll all be dependent on the model. So I think that has covered all the basics of the app. Go in, have some fun with it. You can do some really complex equations if you feel like it. And enjoy that, folks. We'll be back soon with episode 2, which will cover a specific application.